Here's your asynchronous recording for week 3 for Business Math A. We're going to talk about lesson 12 here. So our objectives for today is that students will be able to model data with functions and find the best buy. Students will be able to evaluate bargain shopping algebraically, and students will be able to find good buys based on unit price. So let's talk about some definitions to start. So we got unit pricing is a technique that allows shoppers to compare the prices of various items. Sales tax is a state or local tax on the selling price of an item or service you purchase, usually expressed as a percent. So I'm sure that most of you have seen a sales tax before because you've bought something at a store. Total purchase price is the total selling price plus the sales tax, so that's exactly what you would pay if you go buy, let's say, a pair of shoes. You would be paying the total purchase price of the price of the shoes plus the sales tax. Comparison shopping, comparing prices to find the best value. So those are the 4 definitions that we need to know for lesson 12 in order to be able to complete some problems. So let's start with comparing prices. So sometimes you want to compare prices and see which one is the best to buy. The cheapest ones are the ones with the lower unit price. So some things to consider when buying products. Which one gives you a better price, because of course you don't want to spend too much money on it. How large is the product? So for an example, is it 4 boxes of cereal or is it 2 boxes? Will the product you buy spoil if you buy a large quantity? So if you ever shop at like Costco or Sam's Club, which sell in bulk, you might buy stuff from there that could eventually spoil. So do you plan on using everything in a reasonable time frame? So now let's look at the steps that we're going to use to find the best buy. So step 1, we're going to find the unit price for each item. So to find the unit price, we're going to do item price divided by the measure of count. And then step 2 is find the best buy based on the unit price, because you want the lowest one, because who wants to pay more for a product when they can get it for a cheaper price? So let's do an example. Jackie can buy 12 cups of noodles for $3.48, 20 cups for $5.40, or 50 cups for $11. What is the best buy? So let's go ahead and do step 1. We want to find the unit price for each item. So let's start with the 12 cups of noodle that were sold for $3.48. So we're going to take the $3.48 divided by 12, and we get 29 cents. So now let's do the 20 cups. So they were sold for $5.40 divided by the 20 cups, so we get 27 cents. And lastly, the 50 cups, $11 divided by 50 cups gives us 22 cents. So now let's find the best buy. So the one with the lowest unit price is 50 cups, making 50 cups for $11 the best buy. So let's do another example. Jason can subscribe to Xbox Live for $59 for a year, $30 for 6 months, $12 for 3 months, or $5 per month. What's the best buy? So again, let's find the unit price for each one. So for the year, we are doing 12 months because we're doing this for monthly. So 1 year is 12 months, so we're going to take the 59 divided by 12, so it's $4.92 a month. For the 6 month, we got the 30 divided by 6 gives us 5. 3 months, we got 12 divided by 3 gives us 4. And then don't forget that we also had that $5 per month option. So now we need to look at them and see which one's the best buy. Well, the one that's the cheapest is the 3-month plan, because it is $12 for 3 months. It only costs $4 a month, so that's the cheapest plan. So go ahead, pause the video, see if you can complete this problem. When you're done, go ahead and log back on and we'll see if you got it right. Alright, so now that you've had a chance to do it, you should have gotten that the answer is the 12 for a 10-pound package. If you find all the unit prices, you would want to buy the 12 one. So let's go on to choosing the better plan. Sometimes you have different options for phone plans, rental plans, etc. You have to choose the best option for you based on the price and other factors you may have. If you are given 2 different options, you need to create 2 different equations with 2 different variables. This is called a system of linear equations. So a system of linear equations is a collection of linear equations involving the same set of variables. So here are some examples. So we have 2 systems of equations written down here. We have the 2x minus 3y equals 4 and negative 7x plus 2y equals 3. Then the second one we have is 2x plus 3y equals negative 9 and y equals 4x plus 7. So those are systems of linear equations that we can solve. So let's now talk about the parts of a linear equation. So the most common form is the slope-intercept equation of a straight line, y equals mx plus b. So m is slope, b is y-intercept. Slope is the rate of change, or rise over run. Y-intercept is the point that crosses the y-axis. It's your starting point. So, steps to solving a system of linear equations. First thing you're going to do is choose the variables to represent each unknown. Then you're going to create the two equations for the two different plans, then set the equations equal to each other, and solve for the unknown. So we're now going to complete some examples, and we're going to use these 4 steps as we work through the examples. So example, Marcus is comparing the cost of long-distance calling cards. To use card A, the cost is 60 cents to connect and then 7 cents per minute. To use card B, the cost is 20 cents to connect and then 9 cents per minute. How many minutes would Marcus have to use in order for the cost to be the same? So first thing we're going to do is we're going to choose our variables to represent. So I got x is going to be the minute, since we have like 7 cents per minute and 9 cents per minute, and y is going to be the total cost. So step 2, we're going to create two equations. So if we start out with card A, so it's 60 cents to connect and 7 cents per minute. So we got y equals 0.07x plus 0.60. And then if we do it for card B, we have 20 cents to connect, then 9 cents per minute. So we get y equals 0.09x plus 0.2. Set the equations equal to each other. So since they're both equal to y, we can set them equals. Now what we're going to do is we're going to solve for the unknown. So we want to solve for x. So I'm going to first subtract 0.07x from both sides to get my x values all on the same side. Then I'm going to subtract the 0.2 from both sides so that I have just my x values on the right hand side. Now that I have 0.02x on one side, I want to get rid of that 0.02. Well, since it's being multiplied, I'm going to go ahead and divide both sides by 0.02, so then I get that x equals 20. So at 20 minutes, the cost for the cards will be the same. So if Marcus is going to talk for exactly 20 minutes, it doesn't matter which card he gets. So which one is the best plan? So if we have our cost of both plans, and Marcus plans on talking for 45 minutes, we want to know which one is the best plan if he plans on talking for 45 minutes. So what we're going to do is we're going to take 45, and we are going to first graph it. So we are going to graph our equations. So we have that card A is the orange line and card B is the black line. So we want to know it's at 45 minutes. So I'm going to go ahead and draw a dotted line at 45 so I can easily see right where I'm looking. So if I want to know which one is going to be the best plan, I want the one that costs the least amount of money. So since our y-axis is the cost, I want the graph that is the closest to the x-axis, so the one that I run into first when I start going up. So the one I run into first is card A. So that means that card A is the better plan if Marcus wants to talk for 45 minutes, since the cost is lower for card A. So you can also use the equations to find out. So we're going to use our equations. Now we have the same problem that we just did with graphing, but this time, since we're using the equations, we're going to go ahead and plug 45 in for each equation to the x value and then solve. So we multiply first and then we do our addition. So we get the cost of card A for 45 minutes is $3.75. So let's do the same thing now for card B. Plug in our 45, solve our equation, and we get that the cost of card B is $4.25. So if he wants the best plan, then he's going to want to pay the cheaper price, because who really wants to pay the bigger amount of money? So he would want to use card A, since it costs less if he's going to talk for 45 minutes. So you can find it by graphing, you can find it by plugging it in. So let's do another example. James has 2 different job offers at 2 dealerships across the street from each other. He's got Honda willing to pay him $1,500 per month and then $450 for every car that he sells. He also has Toyota is willing to pay him $2,500 per month and then $350 for every car that he sells. So how many cars would he have to sell per month in order to make the same amount? So first up, we're going to do our unknown. So we're going to do x equals the cars, since we have for every car that he sells, and y is his monthly salary. So now we can create our equation. So if we start out with Honda, Honda's going to pay $1,500 and then $450 for every car. So we get y equals 450x plus 1,500. The next one we have is Toyota's willing to pay him $2,500 per month and $350 for every car. So then we get y equals 350x plus 2,500. So step 3, set the equations equal to each other. And then step 4, we're going to solve. So I want all my x's on the same side. So I'm going to subtract 350x from both sides. Now I want to get my x term all alone, so I need to get rid of that 1500. So I'm going to subtract 1500 from both sides. Now I have 100x and I want x by itself. So I'm going to divide both sides by 100 and get x equals 10. So this means that at 10 cars, the salary will be the same. So if he's only going to sell 10 cars a month, it doesn't matter which job he takes. But he may want to make more money if he sells more cars or less cars, so he may want to also factor that into his decision for choosing which job to take. So go ahead, pause the video, and see if you can complete this problem. Alright, so now that you have had a chance to complete it, Patrick is comparing the cost of renting a bike at the beach. To rent a bike from store A, the cost is $5 to rent and then $2 per hour. To rent from store B, the cost is $8 to rent and then $1.50 per hour. How many hours is the rent cost the same in each store? So remember, we set up our unknowns, create our two equations for each of the bike stores. Then we set the equations equal to each other. Then we go ahead and we solve our equation. So when we solve our equation and we go through the steps, we get that x equals 6. So at 6 hours, the cost for the bike rentals will be the same. So if he's going to know that he's going to ride for exactly 6 hours, he can go to store A or store B. So see if you can do this practice problem. Given the two equations above, which one is the best plan for Patrick if he plans on renting a bike for 7 hours? So go ahead, pause the video and try to complete it. So now that you have completed this problem, let's see how you did. So since we know he's doing it for 7 hours, you can either do this by hand or you can graph it. So I'm going to go ahead and I graphed it. So now since I know it's at 7 hours, I'm going to draw my line up at 7 hours. And then the one that I come into contact with first is the one I would want. So since I come into contact with shop B is the better plan for Patrick. Now, if you were doing this by hand, remember you just plug 7 into each of your equations and then you would get an answer. So that is the end of our asynchronous. This is going to be one of your questions on your check for understanding. Remember, if you still have questions, contact me. Remember that you need to go to the asynchronous activities announcement and click on the check for understanding link to go and do the check for understanding to get your points for this week.